Swayam Prabha. Digital India. Educated India.
So, good afternoon. Let us continue with our discussion on the entry deterrence strategies for an incumbent firm, and the context in which we are discussing about this model is a two-period model, or rather a two-stage model, where in the first stage the incumbent decides on the capacity that it wants to invest in, and in the entrant looks at the capacity choice of the incumbent, then decides whether to enter or not enter. And if there is entry in stage 2, the incumbent and the entrant play Cournot. So, this is the structure in which we are developing the model, and what we had discussed was, we had discussed about the stage 2 Nash equilibrium choices, the stage 2 equilibrium choices, and just to sort of capture the stage 2 choices again. So, if I draw the reaction functions of the two firms. So, we have firm 1 producing an output Q1, firm 2's output is Q2, and what do we know? We know that firm 1's marginal cost is W as long as the output that it produces is less than its capacity choice K1 bar. Its marginal cost is W plus R if it produces an output which is greater than K1 bar. Firm 2's marginal cost is always W plus R, because firm 2 or the entrant does not exist in stage 1, it only enters in stage 2. Now, if you look at so if we were to draw the best response functions for the incumbent and that for the entrant. So, the entrant's best response function is, see, this is the best response function for the entrant, this is the best response function for the incumbent. We know that the Nash equilibrium output in stage 2 can be between T and V, right. So, T corresponds to the case where the Nash equilibrium outcome is symmetric, both the firms end up producing the same output, and the marginal cost for both the firms is also identical, which is W plus R, and V denotes the other extreme, which is the least preferred outcome for the entrant. T is the most preferred outcome for the entrant, because as we move down the best response function for the entrant, notice that Q2 gradually falls. And we also made a note that M1 is the monopoly output of the incumbent, and the monopoly output of the incumbent also corresponds to the Stackelberg choice S. So if we call this T1 and T2, and we call this V1 and V2, we similarly have M1 and M2 as the case where, so let us call it as M1 M2 corresponding to the point S, wherein the incumbent plays the Stackelberg leader output, which is M1, accommodates the entrant, and the entrant enters and chooses to produce M2. So, while we have the entire depiction of the Nash equilibrium outcomes in stage 2, let us ask what is the optimal choice of capacity for the entrant in stage 1. So, the question that we were trying to answer is, what is the incumbent's optimal choice of capacity in stage 1. So, this is the capacity choice which maximizes its profit. Now, so this will depend on where on firm 2's best response function the profit of the entrant becomes 0. So, we need to analyze various cases for that. So, let us do that one by one. So, let us first start with a case which we call as blockaded entry. Okay, so, let us call the case to be the one of blockaded entry. We will understand what this is in just a moment. Okay. So, if we have the two reaction functions, let us first graph those. This is the best response function for firm 2, and as before this is T, and as before this is V, and let us label this to be the monopoly output M1. Correspondingly, the Stackelberg choice is S here. Okay. So, now let B denote the point on the entrance best response function where pi 2 becomes equal to 0. So, let B denote the point on the entrance best response function where pi 2 becomes equal to 0, right. So, specifically consider a point B which is of the form BL. So, let us say B is of the form which is BL. This basically tells us, this essentially means that the profit of the entrant at its most preferred Nash equilibrium output T is essentially negative, right. So, recall T is the most preferred Nash equilibrium output for the entrant, and the point B is at a point which is BL to the left of T, such that the profit of the entrant at the point T becomes less than 0. Now, in this case, well, let us ask, why could such a case arise? Well, such a case might arise if the fixed cost of entry is so large that the entrant cannot even break even at its most preferred Nash equilibrium output, right. So, this could can arise if the fixed cost of entry is very large, right. And in such a case entry by E is never profitable. So, this implies that entry is never profitable, because I am not even doing best in my best possible Nash equilibrium output point T. So, entry is never profitable. So, the incumbent will choose the level of capacity, equal to M1 and produce the monopoly output, again M1. So, this corresponds to the case of blockaded entry. So, the fixed costs are so high that entry is never ever going to be profitable for the entrant. If entry is never profitable for the entrant, it essentially means that the incumbent will set up a capacity so that it produces the monopoly level of output. Okay. Let us consider one more situation where the B, so let us call this 1A, rather let us call this 1A, right, where the B is at BL. Now, let us consider a case where the B is a point which is, let us say, B sub S, right. So, let us say B is a point which is B sub S, right. So, let us say B is a point which is B sub S. Now, so let us call this to be case 1B. So, suppose B is a point which is equal to B sub S, and what is particular about B sub S? Here the entrant is earning positive profit at the point T, but it is gradually decreasing because the output of firm 1 is increasing and the output of firm 2 is decreasing, and eventually at the point B sub S, the profit of the entrant becomes equal to 0, right. So, let us call this as the case where the entrant can break even at T2 or a lower level of output as long as it is above M2, right. So, in such a case, so So, this is, recall, this is T2 and this is M2, right. So, in this case the entrant can break even at a level of output Q2 which is at T2 or lower than T2, but it is above M2. So, we are saying Bs is a point between the T and S such that pi 2 becomes equal to 0. Now, even in this case notice that the incumbent will end up choosing a level of capacity which is equal to M1 and will produce an output which is exactly equal to M1. So, here again the entrant cannot enter, when I produces the monopoly level of output, right. So, here the fixed costs are not as large as they were under the case of blockaded entry, but they are still substantially higher. So, that it becomes equal to 0 at some point between T and S, but the incumbent is still finding it optimal to produce the monopoly level of output, choose the monopoly level of capacity at K1 bar and thereby deter entry. So, I produces the monopoly level of output. So, and in which basically implies that in stage 1 chooses the monopoly level of capacity, okay, chooses the capacity at M1, guaranteeing that the entrant will not enter the market, right. So, we have looked at two possible situations where the B is at BL, the B is at BS, and in both cases it turned out that the incumbent chose a level of capacity which is equal to M1 and produced the monopoly level of output and was able to successfully prevent the entrant from entering, right. So, this is a case where the incumbent enjoys monopoly profits, right. So, in both these cases, so in both 1A and 1B, the incumbent enjoys monopoly profits. Okay. Now, let us look at a case 2 where the B is at a level which is to the right of V, right. So, now let us consider a point B which is, let us say, BH, right. So, let us consider a B which is, rather let us consider a B which is, let us say, somewhere here, which is BH, right. So, let us actually graph this again so as to see it clearly. So, now consider a case right. So, this is the best response function for firm 2, as before this is T, this is V, and let us say we had the monopoly level of output M1 and M2. So, which we called as the Stackelberg point. So, this is M2. Now, we said suppose the B is a point which is BH, which is here, right. So, suppose B is equal to, BH, which is to the right of V, Okay. Now, in this case notice, so this is the point where the entrance profit has become 0. So, this essentially means that even at its least preferred Nash equilibrium point V, the entrant earns positive profit. So, this essentially means that pi 2 at V1 V2. So, this corresponds to V1 and V2, right. So, I have a V1 here and a corresponding V2 here, right, is greater than 0. So, this basically implies that E will definitely enter. E will definitely enter. Now, in order to deter entry, the incumbent would need to set up a capacity which allows it to produce a level of output which is equal to BH, right. But notice, on the other hand, because the incumbent is the first mover, if it simply exploited its first mover advantage and instead chose the Stackelberg level of output, and notice the Stackelberg level of output is nothing but the monopoly level of output, it would have allowed, or it would have accommodated the entrant. Firm I would have produced the output produced by a Stackelberg leader, and firm E would have entered and produced the output which is chosen by a Stackelberg follower, right. So, in this case the outcome would have been at S, right. So, if I were to accommodate the entrant, it would choose the output produced by a Stackelberg leader, right. And notice, this output would be far better than choosing a capacity level of BH and producing BH and preventing firm E from entering. To see this, let us draw the profit curves. If we draw the profit curves, then the firm's profit passing through the Stackelberg point is somewhere here. So, this would be the profit. So, this would be the isoprofit curve of the incumbent when it chooses the Stackelberg level of output. On the other hand, if it were to produce BH and deter entry, this would have been the isoprofit curve, and profit is actually increasing in this direction. So, that tells us that the incumbent is better off accommodating the entrant. So, this is a case of accommodated entry. Entry deterrence is not profitable at all. Here the incumbent is better off being the Stackelberg leader, right. So, I chooses a capacity, the capacity equal to M1 and produces Q1 which is equal to M1, which is the output produced by a Stackelberg leader, right. So, if we just quickly recap the cases that we have talked about, we have looked at cases where the B is at either BL or at BS, in which case the incumbent does not have to try too hard to deter entry anyway would not occur. In one case the fixed cost is so high that entry is blockaded, the incumbent simply produces the monopoly level of output and therefore installs just the monopoly level of capacity. In the other case where the fixed cost is high but not substantially high, again the entrant would not want to enter, the incumbent is better off choosing the monopoly output. And finally, when the fixed cost is low, let us say at BH, then the incumbent is better off accommodating the entrant and being the Stackelberg leader. The most interesting case arises when the B lies between S and V. So, let us analyze that case now. So, let us call it case 3. So, the most interesting case is arises when pi 2 is less than 0, or rather let us pi 2 is greater than 0 at M2, but pi 2 is less than 0 at V2, right. So, in other words, if we were to recap, the two best response functions, this is T, this is V, this is M1, and I have the Stackelberg level of output. So, this would be the Stackelberg level of output given by S, right. So, let us say the B is some point which is here, right. So, let us say the B is somewhere here. It is the profit of firm 2 is positive at S, which is M2, this is M2, and it is negative at V, which corresponds to a level of output at V2. Now, here essentially the incumbent has two choices. Okay, so, say B is equal to, so let us call this B to be some B star, right. So, let us call this to be B star, right. So, now essentially the incumbent has two choices, right. One, it can continue playing the Stackelberg leader output and accommodate the entrant. So, continue to play the Stackelberg leader, output, right. So, continue to play the Stackelberg leader by installing capacity M1, continue to play the Stackelberg leader by installing the capacity at M1 and produce Q1 is equals to M1, or it can expand capacity to B star. So, it can expand capacity beyond M1 and debtor entry. Which one of these two options the incumbent will choose will essentially depend on what its profit is. So, on one hand it can continue to play the Stackelberg leader and debtor entry, in which case, so if we draw the isoprofit curves, of the incumbent passing through, so this would be an isoprofit curve corresponding to the Stackelberg level of output. On the other hand, if it were to produce B star and debtor entry, right, if it were to produce this level of output which is to the right of M1, it would be able to debtor entry, and because profit is increasing as we move down, the incumbent might find it profitable to actually increase capacity and debtor entry. So, here is a case, so here is a case where the latter strategy is more profitable, right. So, the incumbent's isoprofit curve is at a higher level by choosing a level of capacity which is at B star, or let us call it as B1 if you like, right, and it produces an output level which is equal to B1 greater than what a Stackelberg leader would produce, which is M1, right, and would debtor entry. So, essentially the main lesson here is that the capacity choice is greater than M1, and this corresponds to the case of excess capacity to debtor entry, right. This corresponds to excess capacity to debtor entry. So, that is a key takeaway here, right. So, but this is not always guaranteed to happen. This depends on how far is B1, right. So, if the B1 is such that the incumbent finds it profitable to debtor entry as opposed to accommodating the entrant, the incumbent would actually choose that excess capacity and debtor entry. On the other hand, we could have a scenario where the incumbent may simply find it profitable to actually accommodate entry. So, if we call this as 3A, we can get 3B, which is where the former strategy is more profitable. So, if we have Q1 and Q2, so we have the best response functions for the firms, we have firm 2's best response curve, so more importantly we need the M1, and this is the S that we had, and let us say the B1 was somewhere here. Okay, so the B1 or the B star was somewhere here. Now the Stackelberg output, so if we correspond, if we were to, so the isoprofit curve passing through the Stackelberg output level is here, whereas the isoprofit curve passing through B1 is here. So, and this corresponds to, let us say, B1. So, in this case, so here playing Stackelberg leader, and accommodating entry is more profitable. Right. So essentially the whether the incumbent will accommodate entry or deter entry in this setting will depend on what its profits are. In 3A, it turned out that the incumbent was better off deterring entry, its profit was higher by increasing capacity. In the second case, the incumbent is better off simply accommodating entry and producing the Stackelberg level of output. So, in this case the capacity choice is M1 and the output is the Stackelberg level of output. Right. So, in this case the output is the Stackelberg level of output, right. So, this is the entire taxonomy of the entry deterrence and entry accommodation strategies of the incumbent firm. So, the key takeaway here is by judiciously choosing its capacity in stage 1, the incumbent can deter entry in stage 2, right. So, the main lesson here is by strategically overproducing, strategically installing capacity, which corresponds to essentially excess capacity, the incumbent can deter entry. Okay. Now, let us take an example so that we understand what understand the model better, right. So, let us take an example of a model of limit capacity, Okay. So here is this is a game theoretic model. So, this is a game theoretic model. This is a game theoretic model that demonstrates how excess capacity can limit entry in an industry, right. So, the setting that we have is there are two firms which are contemplating entry into an industry. Now, any entry requires investing in capacity, and it could either be a small capacity or a large capacity. So, there are two firms who are considering whether and how to enter, enter, and we will assume that the goods are homogeneous and their marginal cost of production is equal to 0. So, we will also assume that the marginal cost of production of the firms is equal to 0. Now, to enter, firms must build capacity or invest in capacity, and this capacity can be of two types. Or production facility. It could either be a small facility or it could be a large facility, right. What I mean by a small facility is that if it is a small facility, the investment needed would only be, let us say, 50,000 rupees, but the maximum output that can be produced is, so output limit is 100, right. So, if I invest in building a small facility, then the firm would need to make an investment of 50,000 rupees, and the output that I could produce using this small facility is only 100 units. On the other hand, the firm could build a larger capacity, in which case the investment needed would be more. So, that is 175,000 rupees. Let us say these are just sort of stylized numbers, more to prove, more to sort of put structure into the example, but here there is no constraint on the output. So, any number of units can be produced, any number of units can be produced. So, the small capacity is what we call as capacity constraint, and the large capacity is what we call as capacity unconstrained, right, is capacity unconstrained. Okay. Now, let us define the game. So, the firms make their entry decision sequentially. So, firms enter sequentially. So, in stage 1, so first firm 1 decides to enter or not enter, and whether to build a small or large capacity. After observing firm 2's, after observing firm 1's choice of capacity, firm 2 decides whether to enter or whether to enter or not, and if it decides to enter, what is the size of capacity that it needs to build. So, let us shorten this and say that firm 2 decides from the same set of alternatives. That as firm 1 had, right, which is whether to enter or not, whether, and if I decide to enter using a small capacity or use a larger capacity. Now, if both the firms are present, so in stage 2, if both the firms are present, then they play Cournot, the post entry competition. Post entry competition is Cournot, right. So, this is the second stage, which is the Cournot stage, and the first stage is whether firm 1 decides what is the capacity choice of firm 1. Now, if firm 1 is the, so let us start with stage 2, and so we start with stage 2. So, we start from stage 2 and solve the model backwards, and there are a few cases that we need to consider. So, if firm I, where I is 1 or 2, is the only firm in the industry, right, firm I is the only firm in the industry, then what are going to be its profits. Now, we have put structure on the capital investment needed, the marginal cost of the firms. Let us put a structure on the inverse demand curve also. Let us suppose that the inverse demand curve is P equals 900 minus Q1 minus Q2 is the inverse demand curve. Right. So, that we have everything in numbers. So, if firm I is the only firm in the industry, then its profit essentially is, then it's essentially a monopolist. So, that is 900 minus Qi times Qi minus the fixed cost that it incurs, right, depending on whether it is a small capacity or whether it is a large capacity. Now, the output choice of firm I is going to be obtained by setting d pi I dqi to equal 0, which essentially means 900 minus 2 Qi equal to 0. So, the monopoly choice of output Qi star is essentially 450, which then implies that the price Pi is going to be 900 minus 450, which is also 450. So, the profit of the firm I is price times quantity, the total revenue. So, that is 450 times 450, which is rupees 202,500 minus the cost of capacity. Now, notice firm I can produce 450 units only if it has invested in a large capacity, because if it had invested in a small capacity, then its output choice would be limited to only 100 units. So, if firm I had invested in a large capacity, its profit is going to be 202,500 minus the cost of capacity, which is 175,000, that would be rupees 27,500. On the other hand, if I has invested in a small capacity, if I has invested only in a small capacity, then the output, then the maximum output that it would be able to produce, that it can produce is 100, in which case the price would be 900 minus 100, which is equal to 800. So, the profit of the firm I when it has invested in a small capacity would be the price, which is 800 times the output that it produces minus the cost of capacity. The cost of capacity would be 50,000 minus 50,000. So, this turns out to be 80,000 minus, so that is 30,000 rupees, right. So, firm I, if firm I were the only firm in the market, then its profit would either be 27,500 if it had invested in a large capacity, or its profit would have been 30,000 if it had invested only in a small capacity. Okay. So, now let us consider a case 2 where both firms are in the industry. Well, if both firms are in the industry, the post entry competition is essentially Cournot. There are 3 sub cases that may arise. The first sub case is that there are no capacity constraints. So, let us call it as 3A, there are no capacity constraints for both the firms. 2B would be that both the firms are capacity constrained, and case C would be where one firm is capacity constrained, but the other is not. One firm is capacity constrained, the other is not. So, let us analyze each one of them separately. So, let us start with 2A, which is both the firms do not have any capacity constraint, there are no capacity constraint for both the firms. Well, if both the firms do not have any capacity constraints, let us ask what is going to be the post entry Cournot outcome. Well, the profit of firm 1 essentially is going to be the price, which is 900 minus Q1 minus Q2, the marginal cost of production is normalized to 0, times Q1 minus the fixed cost that it pays of 175,000, and the profit of firm 2 is going to be 900 minus Q1 minus Q2 times Q2 minus F2, right. So, again F2 would be equal to F1, which is equal to 175,000, because both these firms have invested in a large capacity, a large facility. So, since the post entry competition is Cournot, both the firms are simultaneously choosing their QIs. So, firms choose Q1 and Q2 simultaneously. So, in other words, if I set d pi 1 dq1 equal to 0, to solve for the best response function of firm 1, we would have 900 minus q1 minus q2 plus, again plus q1 times the derivative of the first term would give me a minus q1. So, that essentially means q1 as a function of q2 is 450 minus q2 by 2. Similarly, for firm 2, if I set d pi 2 dq2 equal to 0, I would again have from the profit function of firm 2, we have 900 minus q1 minus q2 times the derivative of q2, which would give me 1, plus q2 times the derivative of the first term would give me a minus 1. So, that is a minus q2, which is equal to 0. So, that would then give me q2 as a function of q1, which is equal to 450 minus q1 by 2. So, essentially I have two reaction functions or best response functions. So, we have q1, we have q2. So, if q2 is equal to 0, firm 1's choice is 450, firm 1's best response is to produce 450. So, this is 450, whereas if q2 is equal to 900, firm 1's best response is to produce 0 units. On the other, so this is the best response of firm 1, and on the other hand, if we were to draw firm 2's best response, if q1 is 0, q2's best choice is to produce 450, and if q1 is 900, then q2's best response is to not produce anything at all, and the Cournot solution is here. So, if we solve these two best response functions simultaneously, we will have the Cournot output q1 equals q2, which is equal to 300, right. Notice that the Cournot solution is A minus C divided by 3 times B, and our inverse demand curve is 900 minus q1 minus q2. So, A is essentially 900, the marginal cost is 0, and B is essentially 1. So, this gives us the Cournot output as 300. So, which means the Cournot price is equals to 900 minus 600, which is again 300. So, the profit of the two firms are as follows. So, this means that pi 1, so if pi 1 equal to pi 2 is equal to the price times quantity, so that is 90,000 minus the, since this is not capacity constrained, they are investing in a large plant. So, that is 175,000, which gives a negative profit of 85,000 rupees, right. So, this is going to be useful for us later on when we write down this entire game tree. Now, let us look at the second case 2b, where both firms are capacity constrained. Well, if both firms are capacity constrained, then essentially q1 is equal to q2 is equal to 100 units, right. Both have, so neither firm has an incentive to produce less than 100 units. So, neither has an incentive to produce less than 100 units, right. So, in this case, right, so when both the firms are producing only 100 units, the price that will arise is 900 minus q1 minus q2, which is equal to 700, and because they are investing in a small facility, the profit of both the firms pi 1 equal to pi 2 will be 700 price times the quantity that they produce minus the cost of investing in capacity, which is 50,000, because a smaller plant will require a fixed investment of 50,000 rupees. So, that will be 20,000, right. So, this would be the profit that they would earn. And finally, if we have an asymmetric case where firm I is constrained in capacity, but the other firm is not, right. So, the constrained firm, the capacity constrained firm, let us call it firm J, is going to produce, let us say 100 units, right. For the capacity constrained firms only 100 units are produced. Well, if firm J is producing 100 units, right, or rather let us call it as firm 2 to make it more clear. So, let us say the firm 2 or the entrant is producing 100 units, then what is the best response of the other firm? Notice that the best response functions have already been computed, right, because the post entry competition is Cournot. So, if firm 2 is producing 100 units, the best response for firm 1, so firm 1's best response is 450 minus 100 by 2, which is 400 units, right. So, firm 1's best response is to produce 400 units. So, this implies that the price is 900 minus firm 1's output, which is 100, minus firm 2's output, which is 100. So, that is rupees 400 per unit. So, that implies that the firm which is not capacity constrained, which is firm 1, firm 1's profit is the price, which is 400, times the quantity that it produces, which is again 400 units, but then it incurs a it incurs a profit of 16,000 minus 175,000, right. So, this is 160,000 minus 175,000. So, that is minus 15,000, whereas for firm 2, which is capacity constrained, the price at which it sells its product is 400, its output is 100 because it is capacity constrained, but then because it has invested in a smaller facility, its fixed cost of investment is 50,000. So, that is 40,000 minus 50,000, which is minus 10,000, right. So, now notice we have the entire characterization of the profits. We have the profits for case C, where one firm is capacity constrained, the other is not. We have the profits for the case where both the firms are capacity constrained, which is both produce 100 units, and we also have the analysis for the case where both the firms are not capacity constrained, which means both are able to produce as many units as they want. So, let us characterize this in the following game tree. Let us put it in the form of a game tree. So, we next turn to entry decisions. Which can be analyzed using the game tree, right, because the game tree is going to tell us something extremely useful, right. So, the way we would construct the game tree is we would start with the initial node where firm 1 is moving, because firm 1 is the first mover, and firm 1 can either choose to not enter, to invest in a smaller capacity, or to invest in a large capacity, right. So, firm 1 essentially has these three choices: either it chooses to not enter at all, which means it is not going to make any investment decisions in capacity, so it will not produce anything at all, or it chooses to invest in a smaller capacity wherein it will invest 50,000 rupees, or it could invest in a larger capacity where it would incur an investment of 175,000 rupees. Now, at each one of these nodes, after firm 1 has taken its decision, firm 2 makes a move. So, firm 2 can either choose again to not enter, to build a small capacity, or to build a large capacity. Again, in this node, firm 2 can choose to not enter, to build a small capacity, or build a large capacity. And finally, here also firm 2 can either choose to not enter, build a small capacity or build a large capacity. All we need to do is to assign the payoffs at the end of the game tree, and the way we would assign the payoff is that since firm 1 has moved first, we would assign the payoff to firm 1 as the first entity, the second entity will be the payoff of firm 2. Well, the first thing is the easiest. So, if firm 1 does not enter and firm 2 also does not enter, then neither firm gets anything. So, they both earn 0,0. If firm 1 decides not to enter, but firm 2 decides to invest in a smaller capacity. So, let us think about this. So, firm 1 decides not to enter, right. So, if firm I is the only firm in the market and it decided to invest in a small capacity, then its profit would be 30,000, right. So, let us write this as, let us divide it by 1000 and we will say that the profit is normalized to 30. So, firm 1's profit is going to be 0 because it does not enter, firm 2's profit is 30,000 which we will just write as 30. On the other hand, if it invests in a large capacity, its profit is going to be 27,500. So, its profit is 27,500. Now, firm 1 has not entered, so its profit is again 0. So, that is 27,500 divided by 1000. So, we will just enter it as 27.5. Similarly, if firm 1 decides, so we just use a symmetric argument, firm 1 has decided to enter with a small capacity and firm 2 has decided to not enter at all, is just the mirror image of what we have as 0,30. So, in this case firm 1's payoff is going to be 30 and firm 2's payoff is going to be 0, right, because it chooses not to enter. Similarly, if firm 1 has chosen to enter with a large capacity and firm 2 decides not to enter, that is going to be the mirror image of what we have here, right. So, firm 1 gets a profit of 27.5 and firm 2 gets 0 profit. Now comes the case where both the firms are in the market. So, if both the firms have invested in smaller capacity, right. So, if both the firms have invested in smaller capacity which corresponds to case B. So, let us look at what happens in B. If both the firms have invested in smaller capacity, then each gets a profit of 20,000. So, each gets a profit of 20,000. So, essentially firm 1 gets 20, firm 2 gets 20, firm 1 gets 20 and firm 2 also gets 20, whereas if each did not have any capacity constraint which corresponds to 2A, this corresponds to 2A, then their profit is actually minus 85,000, right. So, it is minus 85,000. So, if both have invested in large capacity, they both earn minus 85 comma minus 85, right. So, the last branches that we need to put are where firm 1 is capacity constrained, but firm 2 is not and vice versa. So, in the case where let us say firm 2 is capacity constrained, but firm 1 is not, then firm 1's profit is minus 15,000 whereas firm 2's profit is minus 10,000. So, firm 1 has invested in a large capacity, so its profit is minus 15,000, firm 2 is capacity constrained, its profit is minus 10. So, this is minus 15 comma minus 10, and similarly by symmetry this is going to be minus 10 comma minus 15, this is minus 10 comma minus 15. So, notice we have captured all the profits at various everywhere in the game tree. The way we would analyze this game again is by backward induction, which is we would start at the end of the tree, find out what is happening in each one of these sub games, move back one step and then identify what is the best response chosen by the firm in the previous stage. So, let us start with the sub game which is here. So, let us start with this sub game. Well, in this sub game, suppose firm 1 decided to not enter at all. Suppose firm 1 decided to not enter at all, what would firm 2 do? Well, firm 2 essentially is comparing between not entering, it gets 0, choosing a smaller capacity, it gets 30, whereas sorry, I think if firm 1 decides not to enter and firm 2, so I think let us just check once more. If firm 1 was the only firm in the market, then by setting a large capacity, then with a small capacity it would have gotten 30, whereas with a large capacity it would have gotten 27,500. Okay. So firm 1's optimal choice, or rather firm 2's optimal choice is to go with a small capacity, right. Firm is to go with a small capacity of which gives it a profit of 30 as opposed to 27.5. On the other hand, if we are at this subgame, when firm 1 has decided to enter with a smaller capacity, what is firm 2 essentially doing? Firm 2 is comparing between not entering, it gets 0. If it were to put in a smaller capacity, it would get 20, whereas if it were to put in a large capacity, it would get 15. So, clearly 20 is the largest of that. So, firm 2 decides to invest in a small capacity. Finally, in the third subgame here, if firm 1 had invested in a large capacity, then firm 2 is comparing between not entering, so it gets 0, whereas investing in a smaller capacity which gives it minus 10, whereas investing in a large capacity which gives it minus 85. So, clearly not entering is the best option, right. So now we have a scenario where in stage 2 we have analyzed each one of the subgames and we figured out that if firm 1 decided to not enter, firm 2 would build a small capacity. If firm 1 decided to set up a small capacity, firm 2 would respond also by entering and investing in a smaller capacity, and if firm 1 decided to build a large capacity, then firm 2 would decide not to enter at all. So, when we step back and look at the entire game as a whole, firm 1 essentially is comparing between a profit of 0, a profit of 20 and a profit of 27.5, because these are the profits that it would get in the second stage of the game once it makes its choice. Now, clearly 27.5 is the largest of that and firm 1 decides to invest in a large capacity. So, essentially the equilibrium is that firm 1 invests in a large capacity, firm 1 invests in a large capacity and firm 2 does not enter, right. So let us think about this. This is interesting because, so this outcome is interesting. So, this is interesting because in the absence of any competition, which is in the absence of firm 2, what would have happened? So, if firm 2 would not have been there, so in other words if firm 2 was not there, right, then essentially what would firm 1 have done? Well, firm 1, if it decided not to do anything, would have gotten 0. If it had invested in a smaller capacity, it would have gotten 20, whereas whereas if it had invested in a larger capacity, it would have gotten 27.1. So, clearly 30 would have been the highest profit for firm 1 and it would have preferred to invest in a smaller capacity. So if in the absence of any competition, firm 1 would have invested in a smaller capacity, and would have earned a profit of 30, right. So, if there was no threat of entry, then firm 1 would have invested in a smaller capacity and would have earned a profit of 30,000, right. But firm 1 now considers the threat of entry. right, by firm 2. So, the rational firm 1 then calculates that by investing in excess capacity, which is over investing in capacity by building a larger facility L, it commits to being a tough competitor in the event firm 2 decides to enter. This makes entry unprofitable for firm 2. So, essentially the main takeaway is that if there was no threat of entry, I would have invested in a smaller capacity, but the fact that the entrant would be there, my capacity increases to a large level. Thank you.